studies. Okay? All right, so now we're going to talk about the probability. Okay? So the first one gives you a contingency table. And again, you're definitely going to have a problem with a contingency table. Okay? So the first question says, what is the probability that a randomly chosen vehicle is a truck? So how many vehicles do we have? We have 1,000. How many of them are trucks? Well, we look over, it's a row total, so it's 495. Okay, so 495 out of 1,000 equals 0.495. Okay, so just that's very simple. What's the probability a randomly chosen vehicle is a truck? You look at all the trucks out of the total number of vehicles, and it gives us 0.495. What is the probability that a randomly chosen vehicle is a truck given the information that it's imported? So this would look like, what is the probability that it's a truck given that it's imported? So if you remember, when I talked about doing a given problem with a contingency table, the given tells you the group that you are looking at, tells you your denominator. So in this case, we're given the fact that it's imported. So we look at all the imported vehicles. That's 217. Okay? Out of those 217, how many of them are trucks? Well, that's 74. So it's 74 out of 217, which is 0.341. So again, a given problem with a contingency table is very straightforward. You're given your denominator. That's all the imports. Then you're asked about, of all the imports, how many of them are trucks? In this case, 74 out of 215. Then it says, what is the probability a randomly chosen vehicle is a light truck or an import? So we know that when we see an or, we're adding. But you have to remember that when we're talking about a contingency table, these are all conditional probabilities. So we have an extra step, but let's start. What's the probability something is a truck? So that's the 495 out of 1,000. We're going to add that to the probability something is an import. That's 217 out of 1,000. So this is the probability of a randomly chosen vehicle being a truck. There's 495 trucks out of the 1,000. There are 217 imports out of the 1,000. But because this is a conditional probability, we need to subtract out the ones that are both, because here, these are the trucks, but some of them are imports. And here, these are the imports, but some of them are trucks. So it's like we've double counted. So what we subtract is the ones that are, is a truck and an import, which is 74 out of 1,000. Okay, that gives us 638 over 1,000. Make sure that if you have that fraction, and I've asked as a simplified fraction, that you simplify the fraction, or in this case as a decimal, is 0.638. Okay? And then it says, what is the probability that a randomly chosen vehicle is an imported car? Okay? You could think of this as, what's the probability that it's an import and a car? If you have a contingency table, and it's an and problem, do not do any multiplication. Okay, that just makes it confusing. It isn't that you can't solve it that way, but you will probably, chances are you're going to get it wrong, because it's not a straight multiplication. It's a conditional multiplication. But in this case, we just need to say, well, how many of them are imports and cars? That's 143 out of the total number of vehicles, which is 1,000, and it's just 0.143. So an and problem in a contingency table is actually very, very straightforward. So don't overcomplicate it. Okay?